Now, another thing we're doing with offloads, it's the same philosophy as Azure Boost, but a different implementation. If you take a look at software-defined networking, it consists of lots of rules and lots of processing of those network packets and network connections. Some of the things that the SDN stack has to do, and we implement this SDN stack in something called the virtual filtering platform in Azure, which is inherited from what we had in Hyper-V and a Windows Server, is process things like virtual network rules. What are the security rules for what ports are accessible, whether the network ACLs and routes, as well as things like billing and metering. These things can be extremely complicated, especially for applications that are processing millions of flows. And the kinds of applications that do that are commonly network virtual appliances. So what we're doing, and there's other kinds of workloads that need high amounts of throughput coming off of our remote services like Azure Storage. So one of the things that we're doing, instead of implementing the SDN policies on Azure Boost, is offloading those completely to a disaggregated architecture. You can see this is DPUs, like you saw Satya announce, data processing units that we've got in an SDN appliance. And that's a picture of the back of the SDN appliance right there. There's 6 DPUs in that SDN appliance that can drive a huge amount of throughput and a huge amount of connections per second, coming from anything that's talking through it. One of the actual use case scenario, and by the way, we're also building a smart switch, which is built on top of our SONiC software-defined networking software stack that we developed in Azure and contributed to its open source foundation, something called Dash that supports these DPU offloads on top of SONiC. But if you take a look at one of the scenarios that this supports for us is something called floating NIC, or floating network adapter. You don't even need now to create a virtual machine to support the processing of SDN rules. You can simply create a NIC and say, these are where my SDN processing is happening. Connect that NIC with its IP address to something external, and then all the packets flowing through that get those rules processed, like private link or other kinds of features. We actually got requested by a major AI company that needed extremely high amounts of throughput to back-end storage for their AI training. I can't tell you the name of that company, but it starts with an O. That's all I'm going to say. And they wanted huge amounts. You can see 1.6 terabits per second of throughput to back-end storage. And we could deliver that with this SDN appliance. But the other thing that you get, not just for this kind of remote connection from a different infrastructure into Azure, is something called accelerated connections. Let me show you a quick demo of that. With accelerated connections, I've got a virtual machine here. This virtual machine's network adapter, its NIC, we go click on it and take a look at its properties, we're going to see that it's an accelerated connection network adapter. That means that the SDN for it is offloaded to the SDN appliance. And I've got a tool here called SciPerf, which is going to drive connections per second, among some other things. Up in the top right is the connections per second here. And you can see that the connections per second is close to 1.5 million connections per second, which is a huge achievement to achieve. And by the way, this is completely scalable. If we want more, we just add more DPUs to the SDN appliance, and we can scale it out arbitrarily. So you're going to see us scale this out more and more as we get more and more demand for even higher connections per second.